DeMoivre's theorem. Very powerful theorem. A lot of theory behind it. So let's look at what's going on. Suppose you have the horizontal axis as the real numbers and the vertical axis as the pure imaginary numbers. So where would a plus bi be if a and b are real? So a is here and bi or b is up there. So right here is a plus bi. That is where a plus bi is. So let's get this exact. Keep everyone happy. So that distance is a, and that distance is b. And we'll call that height, or sorry, this length r. And there is a right angle here. Now, it's called the angles theta. Well, it turns out that the sine of theta is opposite over r, and the cosine of theta is adjacent over r. Multiplying both sides by r, we get b is r sine theta and r cosine theta is a. So a plus bi, well, a is r cosine theta plus b is r sine theta times I, and we can factor out the r. So a plus bi is cosine theta r times cosine theta plus I sine theta. Well, what exactly is r and what is theta? Well, Pythagoras will tell us that r squared is a squared plus b squared. But since I only want r will equal to the square root of a squared plus b squared. And I know that the tangent of the angle is b over a. So theta is the arctangent of b over a. So I know what theta is in terms of a and b, and I know what r is in terms of a and b. So I have it all. Now, suppose you want to, so basically we wrote a plus bi, and here it is, a plus bi in this form. This is called r times CIS theta. CIS, and the angles are both theta. CIS theta. So let me give you an a plus bi, something in a plus bi form, and I want to write it in that form. So how about you have 1 plus I? First realize that's 1 plus 1i. Now I want to write this as some r times cosine theta plus I times sine theta. It's probably best to just graph this. You have the real axis and you have the imaginary axis. 1, 1. 1, 1. This is 1 plus 1i. Well, if this distance is 1 and that distance is 1, we know that that's square root of 2. And we even know that this is a 45-degree angle, pi over 4. How convenient. So, we know r is square root of 2, and the angle is pi over 4. Now, let's just make sure we're not losing our mind here. Let's make sure this really equals what we claim it equals. Square root of 2. The cosine of pi over 4, well, it's adjacent over hypotenuse. It's 1 over square root of 2 plus I times the sine of pi over 4 is opposite over adjacent. It is 1 over square root of 2, and the square root of 2 times 1 over square root of 2 is 1 plus the square root of 2 times I times 1 over square root of 2 is just I. And we're getting back what we wanted. We were able to write 1 plus R in, let me just erase our check. We were able to write 1 plus 1I in R cosine theta plus I sine theta form. I mean, it matches up perfectly. R is the square root of 2, left bracket C O S plus, I get that's theta, I S I N, right bracket, theta is pi over 2. Okay, so we definitely were able to write it in the right form. Okay, guaranteed. So that's pretty neat. Let us attempt to do one more like that. Suppose we have negative 1 plus the square root of 3i. So let us graph this. Real axis, imaginary. So we have negative 1, positive square root of 3, right here. That is negative 1 plus the square root of 3i. So this distance is negative 1 and this distance is 3. And we should recognize this as a 30, 60, 90 right triangle. This angle right here is 60 and R is 2. So this is 2 times cosine of 180 over 3, which is 60, plus I times the sine of the same angle. That's done. 1, 2, 3, done. Suppose you wanted to do the same thing to 3 plus 4i. Okay? Real axis, imaginary axis, 3 on the real, 4 on the imaginary, right there. Oops. Right here is 3 plus 4i. This distance is 3. This distance is 4. Wonderful, we have R. So 3 plus 4i is equal to R times cosine of an angle plus I times the sine of an angle. Well, what is the angle? Now, in this triangle, I don't recognize it. I recognize it as a 3, 4, 5 right triangle, but I don't know what the degree is. I can always say that the tangent of the angle is opposite over adjacent, so the angle is the arctan of 4/3. And I actually looked that up just now, and it's about 53 degrees, which is about 0.9273 radians. So we can do that, 9273, 9273. Thing is that would be approximately 3 plus 4i. Be pretty close, but you know, if we wanted the exact answer, we can say that 3 plus 4i is equal to 5 times the cosine of the angle, and the angle is the octant of 4/3 plus I times the sine of, or I know I used a different word, I said octant, but it's the same as tan inverse of 4/3. That's exact. That is exactly the answer. The tan inverse of 4/3 plus, well, 5 times the cosine of the tan inverse of 4/3 plus I times the sine of the tan inverse of 4/3. That is the exact answer. Now, things are really cool with what's going on here. Amazing things happen. Suppose we want to multiply two things like this. That is r1 times cosine of theta 1 plus I times the sine of theta 1 times another one, r times cosine of theta 2 plus I times sine of theta 2. Well, we are multiplying four things. 1, 2, 3, 4. How I multiply them is up to me. I choose to multiply r1 by r2 first. Okay? And then multiply, at least the note that I'm multiplying the other two. Cosine theta 2 plus I sine theta 2. Okay, so this is r1, r2. Cosine theta 1 times cosine theta 2 is just what I said. Now let's get the real part. Multiply those two, you get I times I, which is -1 times sine theta 1 sine theta 2. Let me put brackets around that. Plus everything else, I'll factor out the I. I need to multiply cosine theta 1 times I times sine theta 2. But as I said, I factored out the I. And then I have to multiply I sine theta 1 by cosine theta 2. But I factored out the I. So I get plus sine theta 1 cosine theta 2. Now, the beautiful thing that happens is, this is r1, r2, but that here is cosine theta 1 plus theta 2 plus I. This here is sine theta 1 plus theta 2. So basically, we multiplied the r's and we added the angles. We multiplied the r's and we added the angles, which is pretty neat. So for example, if you have 3 cosine 20 degrees plus I times sine 20 degrees, and you're going to multiply this by 4 cosine 10 degrees plus I times sine 10 degrees, the answer is pretty easy. 3 times 4 is 12, and this times this, well, it's going to be in CIS form. It's going to be cosine of an angle plus I times the sine of the same angle. And what's the angle? Well, just add them. 20 and 10. 30. The other has to be 30 because if that's 20, that has to be 20. And if this is 10, that has to be 10. Otherwise, it's not in our CIS theta form. CIS theta. It must be r times cosine of an angle plus I times the sine of the same angle. So just multiply the r's and add the s, and don't forget to factor out the r. So 1, 2, 3. Now we can go further and figure out what a and b are. We can write this in a plus bi form. That shouldn't be hard. This is 12. Now 30 degrees is 1, 2, square root of 3. So the cosine of 30 degrees is square root of 3 over 2. And the sine of 30 degrees is just a half. So this plus I times a half. Distribute, you get 6 square root of 3 plus 6i. Or if you want to factor out the 6, that's fine. Either one is acceptable. But that's pretty neat how we can get that answer so clean. What about division? What's going to happen with division? What if we have r1 cosine theta plus I sine theta, say 1, and we divide this by r2 cosine theta 2 plus I times sine theta 2. Well, the r's are going to divide. I don't see how that's not going to happen. Now let's look at the rest. Times cosine theta 1 plus I times sine theta 2, sine theta 1, excuse me, divided by cosine theta 2 plus I times sine theta 2. Now, the only thing I can multiply this by is 1. Otherwise, it changed the value. And the one I'm going to pick is going to be the conjugate of the denominator. Remember, if you have a plus bi and you multiply it by a minus bi, you're going to get a squared. You're going to get minus abi, but then you're going to add that back. So that's going to cancel. And positive times negative is minus I squared b. So you get a squared minus, but now I squared is minus 1. You're going to get a squared plus b squared. This is a, that's b, and we're adding ib. This is a minus I times b. That bottom is just going to be this squared plus that squared. That's 1. That's 1. Cosine squared theta 2 plus sine squared theta 2 is 1. And maybe we should write that down for completeness. Okay, so the numerator, well, we're going to have r1 over r2. The numerator is cosine theta 1 plus I times sine theta 1 times cosine theta 2 minus I times sine theta 2. And the bottom is just 1. It's cosine square theta 2 plus sine square theta 2. Okay. Now, this is where we have to be clever. So that's 1, and the rule for dividing by 1 is not to bother. I would love that to be plus. We have cosine theta 1 plus I times theta 1 times, well, if I put in sine of negative theta 2, then I have to put a minus there. So that minus comes out to make the necessary minus. And then the beauty is I can put a minus there. Cosine doesn't care. Now I have a product. Okay, I have a product. Cosine of this angle. So I have CIS theta 1 times CIS another angle. Well, when you multiply, that becomes CIS of theta 1 plus the other angle. But that's theta 1 minus theta 2. That is, I get R1 over R2 cosine of theta 1 minus theta 2 plus I times sine of theta 1 minus theta 2. Okay, so let's look at the end. Let's look at the beginning. Let us see what happened. How can we go from here right to here? Well, first thing is we have to divide the r's. And then we subtract the exponents. The exponents, the angles. The top minus the bottom. And it's in CIS form where it's the top minus the bottom. For example, if somebody asks you what is 3 times cosine of 75 plus I sine 75 degrees divided by 4 cosine 30 degrees plus I times sine of 30 degrees, it's a piece of cake. It's 3 over 4 cosine of subtract. So they're both in RCIS theta form. That's key. RCIS theta form. So we subtract. 75 minus 30 is 45. Plus I times sine of 45. So we get 3/4, and if I'm right, the cosine of 45 is 1 over square root of 2 plus I times 1 over square root of 2. So we get, factoring out the square root of 2, we get 1 plus I. In fact, we get 3 square root of 2 over 8, 1 plus I. Okay, that is exactly what that division gives us. 3 square root of 2 over I. Over 8 times 1 plus I. But things get even better. Things get even better. Suppose that, so now what we just learned was, if you have R times cosine theta plus I sine theta, and you want to square this, that means you want to multiply this by itself 2 times. But we just talked about how you multiply 2 equations in this form. You multiply the r's, and then you're going to get CIS of the sum of the angles, which will be 2 theta, and then times the sine of 2 theta. Well then, If I call that z, this whole thing z, well then this is z squared. Well, z cubed will be z squared times z. Z squared, equals, z squared we just calculated is r squared cosine 2 theta plus I times the sine of 2 theta times z, which is this, cosine theta plus I times the sine of theta. And this is in r CIS theta form, so is that. So we multiply the r's, r squared times r is r cubed, and we add the angles. We get cosine 3 theta plus I times the sine of 3 theta. In fact, I'm not proving this, but I'm motivating it. In fact, z to the n, where z is r, cosine, r times cosine theta plus I sine theta, all to the n. This is r to the n times cosine n theta plus I times sine n theta. We can multiply the angle by n. And also raise r to the nth power. So, we can do things like this now. What if you wanted to find out what 1/2 plus 1/2 I multiplied by itself 10 times? Now, what's inside the bracket is in a plus bi form. So we can write that in RCIS form. But to be honest, I would factor out the half. So you have a half times 1 plus I, the whole thing to the 10th power. So you have 1 over 2 to the 10th times 1 plus I to the 10th. So we want to write 1 plus I in CIS form. Okay. So how you would do that, I think we did this one already. But on the real axis, you'd go out 1, and on the imaginary axis, you would go up 1, and you would get that angle. Let's try to draw it better. And then we'd find r and the angle. Reals, imaginaries, 1 and 1. So that's 1, and that's 1. Well, this is square root of 2, and this is 45 degrees. So we still have the 1 over 2 to the 10. Now I can write this in the form of, well, I'll raise it to the 10th. I'm going to write 1 plus I as r times cosine theta plus I times sine theta. Alright, so we have 1 over 2 to the 10, and on top we have the square root of 2 to the 10th power, because that square root of 2 can factor out. So we have square root of 2 to the 10th power. We have 2 to the 10th power. So I dealt with that. But now I can multiply the angles by 10. This is cosine of 10 pi over 4 plus I times the sine of 10 pi over 4. Now everything's being raised to the 10th power. The square root of 2 over 2, well, 2 is square root of 2 times square root of 2. That cancels out to 1. You get 1 over square root of 2. And if you square it and then raise it to the 5th, I want to square it because then I get a half. 1/2 to the 5th is 1/32. So let me just try to move this out of the way. Okay, so we got 1/32 for this piece right here. 1/32. Now, this angle is more than 2 pi. 10/4 is 2.5. But 2.5 pi. But in terms of sines and cosines, you can just use the 1/2 pi. The 2 pi doesn't do anything. In other words, this is 2.5 pi. We went 1 pi and then 1/2 pi. That's the same as just going from here to here. So this is cosine of pi/2 plus I times same argument, pi/2, and the cosine of pi/2 is 0, and the sine of pi/2 is 1. So we get 1/32 times 0 plus I times 1, which is I/32. This is just I. So you get I/32. Now, what do we know about I/32? Well, if you multiplied what I just boxed by itself 10 times, you would get I divided by 32. That's exactly what you would get. Okay. Now, let us try another problem like this. Suppose you have 1 minus the square root of 3 times I to the 5th. Now you can multiply this by itself 5 times and you'll get the same answer I'm going to get, unless, like me, you made 13 mistakes along the way. Multiplying something out 5 times isn't easy. Well, first let's figure out what's inside. That is, what is 1 minus 3i? 1 minus the square root of 3i. Real axis, imaginary axis, 1 minus 3. So it turns out to be down there. This is 3, negative because it's down. This is 1. 3 squared plus 1 is 10. So the negative 3 squared plus 1 squared is 10. So that's the square root of 10. Okay. So we found R. It's the square root of 10. The question is, what is the angle? And I think I messed up with the numbers that I'm using. Oh, excuse me. As I said, it's square root of 3. So that makes this 2. Negative square root of 3 squared is 3. Plus 1 squared, well, that's 1. 3 plus 1 is 4. This is 2. So this angle is negative 60 degrees. Or, if you prefer, 300 degrees. So we get the cosine of 300 degrees plus I times the sine of 300 degrees. So now, what is the square root of 10 times itself 5 times? 5 times isn't that much, I'll write it down. Radical 10 times radical 10 is 10. Radical 10 times radical 10 is 10 times radical 10. 10 times 10 is 100 times radical 10. Well, it's 10 times 10 is 100 times radical 10. It's 100 radical 10. And these angles get multiplied by 5. So we get the cosine of 1500 plus the sine of 1500. And I'm going to erase a bit, but we want to knock down the 1500. We want to take away multiples of 360. Well, I know that 360 times 4 is what? 1440. Okay, I take away 1440 and I get 60. Oh, so it's 10 square root of 10 cosine of 60 plus I times the sine of 60. And now we draw a 60-degree right angle triangle. This is a 1, 2 square root of 3. So I get 10 square root of 10. The cosine of 63 is 1 over 2 plus I times the square root of 3 over 2. The square root of 3 over 2. I'll bring the 2 out. It'll go into the 10 5 times. So I get 5 radical 10, 1 plus I square root of 3. That is what I get if I actually bothered to multiply that by itself 5 times. Okay, I'm not saying it's easy. I'm saying it's much, much, much easier. Doing it this way is much, much easier than multiplying this by itself 5 times. And, multiplying it by itself 50 times wouldn't have been much harder. Multiplying this angle by 50 and then taking away a lot of 360s wouldn't have been that bad. It wouldn't have been that much harder than the work that I did to go from 1500 to 60. Okay. But this isn't enough, or this isn't all. This isn't all. If you have r times cosine theta plus I times sine theta, and it's all raised to the 1 over n, same thing happens. R to the 1 over n, and you multiply the powers by the angle. So you'll get theta over n plus I times theta over n. Didn't prove that, but that will happen. That will happen. But now, we need to be careful, or we need to be, I guess, clever. Remember that cosine of theta does equal to the cosine of theta plus any multiple of pi n, or any multiple of pi, any integer multiple of pi. That is, this is the same as the cosine of theta plus 2 pi k over n plus I times the sine of theta plus 2 pi k over n. Can always add 2 pi k to the angle that you're taking the cosine of, and nothing happens. You get the same sine and cosine. That is, the sine of 38 degrees is the sine of 38 degrees plus 360. It's the same as the sine of 38 degrees plus 360 times 2. Here it was times 1. Forever and ever. It's also the sine of 38 degrees plus 360 minus 1. The sine of 38 degrees plus 360 times negative 2. It doesn't matter how many 360s you add or subtract from 38. The sine and the cosine and the tangents, they'll all be equal to one another. I'm not saying the sine of 38 is equal to the tangent of 38. I'm saying the sine of 38 plus any multiple of 360s, they'll all be equal. The tangent of 38 degrees is equal to the tangent of 38 degrees plus any multiple of 360. Okay, so now we can do some really interesting things. Okay, we can find the sixth root of negative 64. Find the 6 roots of negative 64. Okay. So we have negative 64, and we want to raise it to the 6th power, and we want to find all the answers. In fact, there are 6 of them. So the first thing you want to do is you want to write negative 64 as 64, has to be positive. Positive 64, in this case, times negative 1. And I'll put everything to the 6th at the end. Okay. Now, this is equal to 64. Now, what equals 1? Sorry, negative 1. Well, let's look at this. Their cosine, now I want negative 1, meaning a real 1, negative 1, not I or anything. Well, give me a second, at pi, the cosine is negative 1, and the sine is 0. So, I want, I knew this before I did this. I want negative 1 plus 0i. And it turns out that the cosine of pi is negative 1, and the sine of pi is 0 times I is 0i. Okay. So, I have this. I was able to write 64, or actually negative 1, in CIS form. Now, you may say, well, wait a minute, where's the R? Well, let's look at this closely. You have the real part, you have the imaginary part, IM, you have the imaginary part, but negative 1 is just here. This here is negative 1 plus 0i. It is just negative 1. And this length is 1. I mean, I'll say times 1 if it's going to make you happier, but it is correct what I have. Okay, 64. Now I want to raise everything to the 6th power. But not so quick. Not so quick. This is 64 times cosine of pi plus 2 pi k plus I times the sine of pi plus 2 pi k. That is, that here is -1 for any value of k. Okay, this gets raised to the 1/6 power. So I have 64 to the 1/6, which is 2. 2, 4, 8, 16, 32, 64. And the other, and this, well, the angle gets multiplied by a 6 or divided by 6. 2 pi k over 6 plus I times sine of pi plus 2 pi k over 6. And this is for k in the integers. Okay. So, just to save space, I'm going to erase this and I'm going to put 2. Now, what values can k be? So this doesn't start repeating. For example, when k is 0, we get pi over 6. That's the angle, because 2 pi times 0 is 0. That pi plus 0 is pi over 6. Now, if k is 1, 2 pi k will be 2 pi. Pi plus 2 pi is 3 pi over 6, which happens to be pi over 2. If k is 2, then this will be 4 pi plus the pi in the front, 5 pi over 6. If k is equal to 3, that would be 6 pi plus the pi in the front will be 7 pi over 6. If k is equal to 4, this piece, well, let me come over here. This piece will be 8 pi plus the pi in the front. We get 9 pi over 6, which is 3 pi over 2. When k is 5, this will be 10 pi plus the pi in the front. That's 11 pi over 6. Now I'll put it up here. If k is 6, that's going to be 12 pi plus the pi in the front. That's 13 pi over 6. But that's 2 and 1/6 pi. You could ignore the 2 and you get 1/6 pi. But we already have that. It's going to start repeating when k is more than 5. Okay. So now we want to find the 6 roots of -64. That is, one number times itself 6 times will give us -64. And we're going to find 6 answers. When k equals 0, we know what angle to use. It's going to be 2 times the cosine of, now we just figured out what this angle is at when k is 2. It's pi over 6 plus I times sine pi over 6. Let me scroll down a bit. Pi over 6 is 30 degrees. 1, 2, square root of 3. So you get 2 times the cosine of that angle is square root of 3 over 2 plus the sine of the angle is a half plus I, and then distributing the 2, we get square root of 3 plus 1I. If you multiply that number by itself 6 times, you will get negative 64 when k is 1. The angle is pi over 2. So you get 2 times the cosine of pi over 2 plus I times the sine of pi over 2. There's the 2. The cosine of pi over 2 is 0 plus I times the sine of pi over 2 is 1. Perfect. I don't know why I wrote that I, but that's exactly what I should get. And here you get 2I. Now, that's a pretty easy one. Just to check what that is. Well, I times I 6 times, that's negative 1 times negative 1 times negative 1. That's negative 1. And so 2 to the 6 is 64. 1I to the 64 is negative 1. Look at that. We found the 6th root of negative 64. It's 2I. Try multiplying that by itself 64 times. 6 times. You will get back negative 64. Okay, now k equals 2. That means we use 5 pi over 6. It's 2 times the cosine of pi over 6 plus I times the sine of 5 pi over 6. So what is the sine and cosine of 5 pi over 6? Well, remember, if I go all the way, I went to pi, 6 pi over 6. So I'm going to go a little bit less. I'm going to go pi over 6 less. So that angle right there, from here to here, is 5 pi over 6. But this reference triangle tells me the sine and cosine of this angle. This is 1, this is 2, this is negative square root of 3. The cosine of this angle is negative radical 3 over 2, negative radical 3 over 2, plus I times the sine of this angle is 1 over half. And when I multiply by 2, I get radical 3 plus I. Fairly similar to that answer. Okay, that is when k is equal to 2. When k is 3, the angle is 7 pi over 6. So when k is 3, I get 2 times the cosine of 7 pi over 6 plus I times the sine of 7 pi over 6. And this is equal to 2 times something. Well, what is 7 pi over 6? Well, once again, that's 6 pi over 6, or pi. I have to go pi over 6 further. So this reference angle is pi over 6, 30 degrees. We get 1, 2, radical 3, left, negative because it's to the left, negative because it is down. The cosine of this angle is negative square root of 3 over 2 plus I times the sine of the angle is negative 1 over square root of 2. So this is, okay, let's write it as plus. Negative 1 over 2. Negative 1 over 2. Distributing the 2, we get negative square root of 3 minus I. And it makes sense because these two differ by a minus sign. And if it turns out that this to the 6th power is negative 64, then negative this, let's say negative 1 this to the 6, well, that's 1 to the 6 times radical 3 plus I to the 6, and negative 1 times itself an even number of times will be 1 times 64. Sorry, this is negative 64. Will give you negative 64. Okay, and we're going to get the negative of this one too. Okay, now k is 4. So we're also going to get the negative of 2i. We'll get negative 2i. Because the negative to the 6th power is 1. So there's really only going to be like 3 distinct ones. Some are going to come in pairs. These are just negative of one another. And we're going to get the negative of this and this. When k is 4, the angle is 3 pi over 2. So we get 2 times the cosine of 3 pi over 2 plus I times the sine of 3 pi over 2. And the cosine of pi over 2 is 1. And sorry, it's 0. And the sine of 3 pi over 2 is negative 1. So we get negative I, which is negative 2i. As promised. We got that pair. Now, if I don't make a mistake, I bet you I'm going to get radical 3 minus I next. When k equals 5, I use that angle. 2 times the cosine of 11 pi over 6 plus I times the sine of 11 pi over 6. Oops. Alright, so there's the 2. 11 pi over 6. Well, 12 pi over 6, that's 2 pi. Minus 1 pi over 6 minus 1 pi over 6, well, that's 11 pi over 6. So I don't quite just go 2 pi, I go pi over 6 less than that. Okay? So I don't quite go all the way around, I'm just pi over 6 shy of going all the way around. This is 30 degrees. 1, 2, square root of 3. Since this is down, it is negative. Since this is to the right, it is positive. The cosine of this reference angle is radical 3 over 2. Radical 3 over 2. Their sine plus I, maybe minus, I don't know. The sine of this angle is, yep, negative 1/2. So you have negative I over 2. When you distribute, you get square root of 3 minus I, which is exactly what I said we'll get. We'll get the negative of that. And that's going to happen a lot when you have an even root. Okay? If I tell you, and no promises, if I tell you 7 plus 2i to the 10th power is negative 19. Okay? If I tell you that, well then yeah, negative 7 minus 2i to the 10th. Well, what's in here is negative 1 times 7 plus 2i raised to the 10th. So you get negative 1 to the 10th. 7 plus 2i to the 10th. Negative 1 to an even power is 1. And I'm just making up that that's negative 19. So yeah, I get back negative 19. So when you have an even power, and you're going to have complex numbers because it's negative, they're going to come in pairs. They're going to be pairs, meaning if you have a plus bi as an answer, you're going to have negative a plus bi. They're going to come in that kind of pairs. Not conjugate pairs, but negatives. Get a plus bi, which is negative a minus bi. These are not conjugate pairs. They're negative of one another. And of course that's going to be true if you have an even power. Now even if it isn't negative, or even if this isn't real, well yeah, you still get negatives. Okay, that pretty much finishes this section on DeMoivre's theorem. You can now find the roots of, or the seventh roots of 11. You can find the 15 roots of 3. You can find the 5 roots of 1. You can find the roots of unity. Maybe we will try one. What are the 3 roots of unity? What are the 3 roots of unity? Unity means 1. So, what is 1 to the 3rd? Well, 1 is cosine of 0 plus I sine of 0. Because cosine of 0 is 1 and sine of 0 is 0. That is, it is cosine of 0 plus 2 pi k plus I times the sine of 0 plus 2 pi k. Don't have to bother denoting, writing the 0. Okay. This is 1 to the 3rd. This is 1 to the 3rd. Well, this equals to the cosine of 2 pi k over 3 plus I times the sine of 2 pi k over 3. Now, we should let k equal 0, 1, and 2. 1 less than 3. Because if we let k be 3, then this will be 6 pi. But that is 6 pi in a way. Actually, it'd be 2 pi. 2 pi times 3 divided by 3 will be 2 pi. But that's 0. Okay, so no point in going up to 0, up to 3. So now what we want to do is see what we get when we plug in 0, 1, and 2 for k. Well, if k is equal to 0, then 1 to the 3rd is equal to, well, if k is 0, we get cosine 0 plus I times sine 0, which is 1. Okay, and sure, the cube root of 1 is 1. What about when k is 1? We get the cosine, well, if k is 1, the angle is 2 pi over 3. 2 pi over 3 plus I times the sine of 2 pi over 3. Now, the 2 pi over 3, well, pi over 3 is 60 times 2 is 120. It's just short of 180. it is 60 degrees short of 180. So the cosine of 2 pi over 3 is the cosine of this triangle. 1, 2, square root of 3. Since this is to the left, it's minus. Since that's up, it is positive. The cosine is negative 1/2. Negative 1/2. Plus I times the sine is square root of 3 over 2. The square root of 3 over 2. Okay, that is a second answer. Let us look at the third answer, and then we'll verify one or two of them. When k is 2, this angle will be 4 pi over 3. The cosine of 4 pi over 3 plus I times the sine of 4 pi over 3. Well, pi over 3 is 60 times 4 is 240. This is 180 and 60 more. The cosine of this angle is just, that is the cosine of 240 is just the cosine of this reference angle. This is 1, 2, square root of 3. This is going down, so it's negative. This is going to the left, so that's negative. The cosine of this angle is negative 1/2. It's negative 1/2. The sine of this angle is minus square root of 3 over 2. Minus square root of 3 over 2i. These are the 3 roots of 1. 1, the cube root of 1, has 3 answers. Now, I said I'll try 1 or 2 of them. Now, one of them I'm not even counting. 1 cubed is 1. What do we get when we cube this? Negative 1/2 plus I times square root of 3 over 2. Well, first of all, I'm going to factor out the half. I get negative 1 plus I radicals 3. Now, I want to cube. So I can cube this and cube that. Well, 1 cubed is 1 over 8. Well, it better be that this cube is 8. Let us see what we get. Negative 1 plus I times square root of 3. I'm going to multiply it by itself 2 times. Actually, let me write down all 3 times. That gives me 1. That takes away I square root of 3. This takes away another I square root of 3. And this, well, square root of 3 times 3, square root of 3 is 3. So this is minus 3. And I multiply this by this. And what I get is 1 minus 3 is negative 2 minus 2i square root of 3's times negative 1 plus I square root of 3. And negative 2 times negative 1 is 2. Negative 2 times I square root of 3 is negative 2I square root of 3. And then we get plus 2I square root of 3. So that cancels out. Then here, the I times I is negative 1 times the negative in front becomes positive, and you have 2 times the square root of 3 times the square root of 3. Square root of 3 times 3 is 3 times 2 is 6. Look at this. 2 plus 6 is 8. Times 8 is 1. This is the cube root of -1. Sorry, the cube root of 1. That is the cube root of 1. And I'm going to stop right there. So this stuff is really neat. You can find the cube root of unity. You can find the seven roots of 1. You can find all 7 of them. There are 7 of them. There are also 9 of them. We found 3. We found the 3 roots of unity. You can find the 7 roots, the 9 roots. You can find them all. Okay? Nobody's saying that the roots that we just found here will be, so we found 3 of them. I am not saying that we'll find the same 3 here and then another one. I'm not saying that. We will find the 4th root of 1. Okay, there's no reason to think that they're the same. For example, the 2nd root of 16 is 4. The 4th root of 16 is 2. Or, just ignore that. That you don't have to, okay, so maybe not ignore it. 1 root of 16 is 4. The 1/4 root is 2. But, for example, 2 is not going to be a root here. 4 is not going to be a root there. They don't have to be. If you're finding 3 roots here and 4 roots here, there's no reason why this 3 that we found here should match 3 down here. Okay, they don't. Just ignore all that. Okay, but this is beautiful stuff. This excites me, as you can see. Good luck with it.